Hi friends, today I am going to discuss about the very interesting topic model parameters and hyperparameters in machine learning deep learning. So this part I can divide into two parts. Part 1 I am going to discuss about the theory. So second part I am going to discuss about the implementation. So today's agenda is what are the model parameters, what are the hyperparameters, what is hyperparameter tuning, comparison between the parameters and hyperparameters tuning methods. So in machine learning deep learning, model can be defined by the model parameters. So basically there are two types of parameters. One is model parameters, second one is the hyperparameters. So now we are going to discuss in detail. So what is model parameters? So model parameters are the configuration variables that are internal to the model, and model learns them its own. So these parameters are estimated by the model from the given data. So what is the data we are going to provide? So from the data, so it is going to estimate it. So these are the parameters in the model that must be determined using the training data set. So basically data can be divided into two types, trained data set and test data set. So we are going to divide the data like 90% for training, 10% for test data, or 80% for training, 20% for testing. So what is the percentage we are going to take? So on this data is the training data set. So on the training data set, so by using this training data set, we are going to determine the model parameters. So these are the fitted parameters. So while training the model, so parameters are continuously updated, and final ones at the end of the training constitute your model. So while training our model, so the parameters are always going to updated. So for example, weights are the coefficients of the independent variables in the linear regression. So weights in the deep neural network. For example, in linear regression, y is equal to mx plus b. So here m and b we used to call the model parameters. Next. So if you see this diagram, we can understand the model parameters from the below image. So in this given image, so this is the red dots are the our given data points, which means our target variables. So the above plot shows the model representation of the simple linear regression. So simple linear regression formula is equal to y is equal to mx plus b. So here x is our independent variable and y is our dependent variable. So this is our dependent variable y and this is our given independent variable, and our goal is to fit the best regression line. So best regression means here this is the line is our regression line. So regression line means y is equal to mx plus b. So we have to identify the relationship between the x and y. So x is nothing but the independent variables and y is nothing but our target variable. So the regression line is given our equation. So what is the equation? Y is equal to ms plus b. So in y is equal to ms plus b, in this equation m is nothing but our slope of the line and c is nothing but the intercept of the line. So these are the two parameters. So in this equation m and c, these are called the parameters, model parameters. So these two parameters are calculated by fitting the line. We have to minimize the error. So error is nothing but the root mean square error. So whenever we are going to minimize the error, so that is the best fitted line. So these are some of the key points for model parameters. So the model use the use this parameter for making the predictions. So they are the learned by the model from the data itself. So which means the model parameters can learn from the data. So data means training data. So these are usually not set manually. So this is the parameters m and b. These parameters we are not going to set manually. So these are the part of the model and key to the machine learning algorithms. Next. So what is the model hyperparameters? So here the parameters are cannot be estimated by the model. So this is the parameters cannot be estimated by the model from the given data. So what are the data we are given? So from the data we are not going to calculate the hyperparameters. So these are the parameters are used to estimate the model parameters. So for estimating the model parameters we are going to use this hyperparameters. So what is meant by hyperparameters? Let's see. So hyperparameters are those parameters that explicitly defined by the user to control the learning process. So while training the model, for controlling the learning process we have to set manually by the user. So these are the usually defined manually by the machine learning engineer. So one cannot know the exact best values for the hyperparameters for the given problem. So suppose any problem, if you supposed to take either regression problem or classification problem, so for getting the best result you need to apply some of the parameters. So but nobody knows which parameter we are going to which parameter is giving the best results. So until you execute by trial and error method, so nobody knows what best parameter can able to identify for getting the best result. Next. So the hyperparameters are the adjustable parameters we must tune in order to obtain the model with the optimal performance. For getting the optimal performance we need to tune this parameter. So you set the hyperparameters before training begins. So while before training the model you need to set these parameters manually. So therefore setting this right parameter value is very important. So many parameters are there. For example, if you take learning rate, so learning rate people used to take 0.1, 0.001, 0.0001 like that. So nobody knows which parameter, which learning rate is giving the best result. So that is our main goal is to have to set the right hyperparameter value is very important. So for getting best result we want to select the best learning rate. So learning rate is the part of the hyperparameter tuning. So the selecting the best hyperparameter value directly impact the performance of the model. For example, learning rate if you suppose take 0.01, for example the R square value may be 90%. If you suppose to take 0.001, the R square may be 95%. So nobody knows which learning rate giving the best result. So that's why the performance of the model depends upon the best hyperparameter value. So the process of choosing the best hyperparameter is called the hyperparameter tuning. So for example, learning rate in deep neural network. Next. So basically anything in machine learning and deep learning that you have to decide their values before training begins and whose values will remain the same when the training ends the hyperparameter. So if you see this example, so if you want to build a simple linear regression, so simple linear regression formula y is equal to mx plus b. So here you can write like this. So here m dimensional. So m dimensional means the number of columns or the variables or the features. So here m is different, this m is different. Suppose if you, instead of this equation, if you supposed to take y is equal to beta naught plus beta 1 into x. Okay, so this is beta 1, beta naught are the parameters, model parameters, and here m is nothing but the number of dimensions. Suppose here x is our independent variable, means predictor matrix, and w is nothing but the our weights. Here w is nothing but the beta naught. People can able to write like w naught plus w1 x like that. So here the w naught, w1, w2 up to wn is the modal parameters, which means suppose if you take m number of parameters, in place m is equal to 3, so which means y is equal to w naught plus w1 x1, w2 x2, w3 x3, which means number of dimensions is equal to 3, which means 1 2 3. So number of features are 3. So if the model uses the gradient descent algorithm, so what is mean by gradient descent algorithm? So I already explained about this algorithm in my previous lecture, that lecture number 4. So if you want to know full information about this gradient descent algorithm, you please watch my lecture number 4. So here GDA algorithm to minimize the objective functions in order to determine the weights. So here you are going to identify the weight values at the end of the training. So after training, once you calculate these weights, which means that your model is properly trained. So here learning rate, eta is nothing but the learning rate, and n iterations is nothing but the number of iterations. So this learning rate, number of iterations, this is the part of the hyperparameter tuning. So the hyperparameters that would have to adjusted in order to obtain the best values of the modal parameters. So in case of classification, that is the random forest classifier. So some of the important hyperparameters are the n estimators. N estimators is nothing but the number of decision trees. So random forest is nothing but the combination of the trees. So that is the number of trees. So max feature, maximum number of features consider while splitting. So max depth, so max depth of the tree. Minimum samples leaf means minimum number of data points in the leaf node. So these are all the hyperparameters of the random forest. So finally, hyperparameter tuning is finding the best combination of the hyperparameters and that give the best performance according to our different scoring matrix. So if you see this example, so here defining the random forest classifier hyperparameters, n estimators 1, minimum samples leaf, max depth 3, 1 2 3 4 5. So here number of estimators can take in the range from 50, 100, 200, 300. So 1 2 3 4. So 4 values they are considering for the n estimators. We don't know which is the best value. Like minimum samples they are taking the 1 5 10. So among the 5 1 3 1 5 10 we don't know which is the best value. So like that we are taking the sum of the hyperparameter values, and you are going to apply this some grid set CV. In the grid set CV you are going to apply the cross validation. Cross validation you are taking the 5. People used to take generally cross validation 5 10 like that. So about cross validation I already made a video, you please watch that video also. So you are going to apply the grid set CV to have to identify the best hyperparameter values. So when you apply this model grid set CV, so it will give the best parameters. So if you see, among the bootstrap it identify the true from the true itself, and max depth is 10. So here from the max depth it is identified the 10, and max features is SQRT, and minimum samples leaf 1, and n estimate is equal to 300. So here grid set CV, while apply the grid set CV with cross validation of 5, so the model identify the best parameters. So if you pass these best parameters while training the random forest classifier, it will give the optimal result. So about practical I am going to explain in next video, don't worry. So if you see, so here how many estimators are there? 1 2 3 4, 4 estimators, and a depth 1 2 3 4 5, 5 values. Leaf will be 1 2 3, maximum features 1 and 2, and boost of 1 and 2. So if you multiply with all those things, 4 into 5 into 3 into 2 into 2, so like that 4 into 5 into 3 into 2 into 2, so it will be total number of combinations are the 240. So after the 240, so the grid cells we select the best combination of the parameters. So hyperparameters of the deep learning. So parameters related to the more to the optimization for training the process than the model itself. So these parameters help to tune the or optimize our model before actual training process starts. So what are the main hyperparameters of the deep learning? Learning rate, mini batch size, and number of training iterations, like nothing but the number of epochs. So this is the general hyperparameters in the deep learning. So train test split, here train test split ratio, which means you are going to divide your data into training and testing at 90 per, like that. Nobody will say which is the best percentage ratio. So you have to do trial and error, 90 10, 80 20, 70 30. So like that you need to divide the data set in the ratio train test split method. Like that, learning rate in the optimization algorithm. So what is the optimization algorithm here? Gradient descent algorithm. So choice of optimization algorithm, gradient descent or stochastic gradient descent, Adam optimizer, like that. So you have to choose, you have to apply trial and error. So choice of the activation functions in the neural network. So many activation functions are there. For example, sigmoid activation, ReLU activation, TANH, like that. So number of hidden layers in the neural network, number of activation units in each layer, and a dropout ratio, and a number of iterations in the number of epochs, and number of clusters in the clustering tasks, and kernel or filter size in the convolutional layers. So in the CNN architecture, and filter size will be 3 by 3, 5 by 5, 7 by 7. So this is the part of the hyperparameter. And pool size will be 3 by 3, 2 by 2, like that. And batch size will be 8, 16, 32, 64, 128. So people used to play with these hyperparameter values for getting the best result. So examples of the hyperparameters used in the scikit-learn. So train test split estimator. So here test size is equal to 0.4, which means that training ratio is 60% and test ratio is 40%. And the lasso regression. So about the lasso regression, I already made a video, so you can go and watch it. So in the lasso regression, the alpha is the hyperparameters. So hyperparameter, we are going to give the value 0.1, 0.001, 0.001. So this is the regularization parameter. So with the regularization parameter, you can able to give the some range of the learning rate values. Principal component analysis. So this is the PCA. So it is unsupervised learning algorithm. So PCA is used for the reduce the dimensionality. So I already made a video about this PCA. Please go and watch that video. So in the PCA, a number of components. So here this is the value. This is the value will decided by the data scientist. So here you are going to choose how many components you are going to reduce. For example, your data will be n. For example, n is equal to 100. Dimension will be 100. So when you apply the PCA, so you are going to reduce the dimension from 100 to how much dimension you are going to reduce. So you are going to reduce 50 means you are supposed to provide the 50. If you are supposed to want the 30 means you are supposed to provide the 30. So this is the value you are supposed to decide. So it is important that during the model building, so the hyperparameter fine tune in order to obtain the highest quality. If you see this a good example of how predictive power of model depends upon the hyperparameter. So if you see this diagram, in this diagram, so this is the regression data points, so this is the target variables. So here n value is nothing but, sorry, here this is the learning rate value, so 10 power 1, 10 power minus 1, 10 power minus 2, 10 power minus 3. Whenever this is called the learning rate, whenever learning rate is going to decrease, so automatically the accuracy R2 score value somewhat increasing. So among the regression line, among the data points, which line is going to pass the most of the data points? So if you see this diagram, in this diagram, so the learning rate is 10 to the power minus 4, which means the R square is 0.483. So compare, this is 0.42, this is 0.483. So this is the 10 to the power minus 3, 10 to the power minus 4. So compared to this diagram, here this regression line, this black line, it can pass through the most of the data points, which means here compared to this 1, 2, 3, 4, 5, this compared to these 5 figures in this figure, so this error is very less. Error is very less means the accuracy R2 score is more. From this figure, you can see the reliability of our model depends on the hyperparameter tuning. If we just pick the random values for learning rate, such as eta is nothing but this is the learning rate 0.1, this would lead to the poor model. If you choosing the value of eta value is too small means 0.00001, so it can produce the bad model. So based on, so model is bad model or good model depends upon the hyperparameter, here learning rate. So suppose here taking the best choice value when 0.001, which means here 10 to the power minus 4, here R score value is 0.483. So here R score value depends upon the learning rate. So hyperparameter is here, learning rate is the hyperparameter value. So best model result is depends upon the hyperparameter value. So here comparison the table between the parameters and hyperparameters. So if you compare here the parameters that are configuration model, which are internal to the model, here explicitly specify the parameters that control the training process. So this is the main difference between these parameters, and this is the model parameters and this is the hyperparameters. So these model parameters are essential for making predictions. Here hyperparameters are essential for optimizing the model. So these are the specified while training the model. So while training the model, you have to specify these hyperparameter values, and these are the you have to set before training the model. So before going to train the model, you are going to set the some of the hyperparameter values like learning rate, like that. So this is the internal to the model, this is the external to the model, and this is the learned and set by the model itself, and this is manually you have to manually by the machine learning engineer you have to set the hyperparameters. So these are the dependence on the data set. So depends on the data set, which depends upon the training data set. So this is the independent on the data set. So it is not depends upon the data what you are going to take in. So it is depends upon the what is the values you are supposed to given to the model according to the according to the model you are going to provide the hyperparameters. So these are the values of the parameters can be estimated by the optimization algorithm. So optimization algorithm is what is that gradient descent algorithm. So this is the values of the hyperparameters can estimated by the hyperparameter tuning. So the final parameters are estimated after training decided by the model performance and the unseen data. So the selected of the fine-tuned hyperparameter decided by the quality of the model. So some of the examples for the model parameters are the here in linear regression, y is equal to mx plus b. Here m and b are called the model parameters. Here hyperparameter is learning rate 0.1, 0.001 like that. And if you supposed to take neural network, if you supposed to take in the number of layers, number of hidden layers and epochs, batch size, like that. And what is the hyperparameter tuning methods? They are the two important popular methods, that is the random search, grid search. So random search is the random search method. We can create the grid of the possible values for the hyperparameters. So each iteration tries to random combination of the hyperparameters from this grid, records the performance, and lastly return the combination of the hyperparameters that provide the best performance. So I will give the clarification between the difference between the grid search and randomized search. So in the grid search method, we create the grid of the possible values for the hyperparameters. So each iteration tries to combination of the hyperparameters in the specific order. So here if you see this example, if you suppose to provide this is the parameters you consider. If you suppose to take the random search, what will happen? So randomly it will combine it will take this value and this value, this value and this value and this value, and will take the one combination. So like that it will take this one, this one, this one, this one, this one. So like that from every hyperparameter it will identify the one value randomly and make the combination. This combination will give to the model for fitting. So this is the randomly selecting the from each hyperparameter. If you suppose to take grid search, so grid search means this is the permutations and combinations. So from this one 1 2 3 4 5 this combination. So after that like that from this thing, so from this thing this is the combination it is going to choose. So this is the compared to random search, the grid search will give the it will perform the best it will give the best results, but is grid search it will take the time taken process and it will consume the more resources, but it will give the best combination of the parameters. It will give the best combination of parameters compared to the random search. Random search is only randomly pick up the sum of the values and will take the combination, it will feed to the model. But grid search it will take each and every permutation, each and every value of the parameter like a permutation combination, and it will apply it will give all possible combinations to the model. That's why this is the grid search it will take time taken process, it will consume the more resources. So this is the parameters of the this is the difference between the parameters, model parameters and the hyperparameters. In next video I am going to explain about the implementation. I hope you understand this concept. Thank you.